Cylinder. Cylinder is a surface generated by a straight line which is always parallel to a fixed straight line and intersect the given curve. The fixed straight line is known as the axis of the cylinder. The given curve is known as guiding curve, and the rotating line which when rotated about the axis generate the cylinder is known as generator. So this is the cylinder, guiding curve, generator and axis. Projection. So suppose we want to find a projection of the line segment AB, the coordinates of point AR x1 y1 z1 and of the BR x2 y2 z2 on the line L. So from every point on the line segment AB, draw a perpendicular to the line L. So from A will get point A dash, from B will get the point B dash, and from every point between A and B will get the points between A dash and B dash. So A dash B dash is the projection of AB on the line L. And how it is given? It is given by, this is the formula, direction ratios of AB. To find the projection of AB, therefore direction ratios of AB into direction cosines of the line L. So direction ratios of AB are x2 minus x1, y2 minus y1 and z2 minus z1. Suppose direction cosines of line L are L, M, N. Then find the component wise multiplication and then we will get the A dash B dash. So A dash B dash equal to L x2 minus x1 plus M y2 minus y1 plus N z2 minus z1. So here our aim is to study specific type of cylinder known as right circular cylinder. So it is a surface generated by rotating a straight line and intersecting, in previous part we understood that intersecting a given curve. So here the given curve is a circle and therefore it is known as a right circular cylinder. The fixed straight line is known as axis, the rotating line is known as a generator. If you take intersection of the plane which is perpendicular to the axis of cylinder and the cylinder, then it is a circle. So the right circular cylinder is like this: circle, axis and generator. Okay, now our aim is to find equation of the right circular cylinder. And to find the equation of right circular cylinder, as I think you remember, in case of the right circular cone, we use the concept of angle between the axis and generator. Okay, here we are considering the concept of Pythagoras theorem. So see what is given. To find equation of a right circular cylinder of a radius r, so radius of cylinder is given and whose axis is the line, equation of axis is given: x minus alpha by a equal to y minus beta by b equal to z minus gamma divided by c. So draw the cylinder and start like this. You might have understood AB is the axis of cylinder. Suppose P is any point on the surface of cylinder, general point, therefore its coordinates are x, y, z. From point P, draw perpendicular to the axis that will meet the axis in point M. So angle AMP is a right angle. So the triangle is a right angle triangle. Then we'll start like this. AB is the axis of cylinder, it should be cylinder, and its equation is x minus alpha by a equal to y minus beta by b equal to z minus gamma by c. So it is very clear that alpha, beta, gamma is a point on axis. Direction ratios of axis of the cylinder are ABC. So direction cosines are required and they are denoted by L, M, N. L is given by a divided by root of a square plus b square plus c square. M is equal to b divided by root of a square plus b square plus c square, and n equal to c divided by square root of. Okay. Now the coordinates of point A are known: alpha, beta, gamma. Distance AP is given by square root of x minus alpha square plus y minus beta square plus z minus gamma square. PM is the radius of cylinder and it is given in example, it is r. AM, understand that AM is the projection of AP. So if you draw perpendicular from each and every point on the line segment AP on the axis, we'll get the AM. So what is AM? It is a projection of AP on the axis, and it is given by direction ratios of AP into direction cosines of axis. Coordinates of A are known, coordinates of P are known. From their direction ratios are obtained: x minus alpha, y minus beta, z minus gamma. Then direction cosines of axis are known, L, M, N. So component wise multiplication will give m, L into x minus alpha plus m into y minus beta plus n into z minus gamma. Then since triangle AMP is 90 degree, Pythagoras theorem is used, and it is AP square equal to PM square plus AM square. The value of AP, PM and AM are substituted, and if we simplify this, we'll get an equation in terms of x, y, z, and that is the equation of required right circular cylinder. Type number 1, a radius of the cylinder is given. These are the simplest examples. So we'll start with the first example. Find equation of a right circular cylinder of a radius 3 and axis is the line x minus 1 by 2 equal to y plus 1 divided by minus 1 equal to z minus 2 divided by 3. So we'll start with see how the cylinder is drawn. Here AB is the axis of cylinder. A is any point on the axis which can be obtained from the equation of axis. From the point P, a perpendicular is drawn to axis that will give the point M. So angle PMA is a right angle. So start with the axis. Axis of the cylinder is x minus 1 by 2 equal to y plus 1 by minus 1 equal to z minus 2 divided by 3. So 1 minus 1 2 is a point on the axis, and direction ratios of axis are 2 minus 1 3. That is a equal to 2, b equal to minus 1 and c equal to 3. From there we can find direction cosines of the axis, and that is L equal to L equal to a divided by root of a square plus b square plus c square, that is 2 divided by square root of 14. M equal to b divided by square root of a square plus b square plus c square, that is minus 1 divided by square root of 14. And n equal to 3 divided by square root of 14. Now we'll start with the different distances. So distance PM is the radius of cylinder, and it is given in example, it is 3. AP by distance formula is root of x minus 1 square plus y plus 1 square plus z minus 2 square. And AM is, understand what the AM is. So again, if you draw perpendicular from each and every point of the line segment AP on the axis, that will give the AM. So AM is projection. Whose projection? Of the AP on axis. So let me write that. So AM is projection of AP on the axis, and it is given by direction ratios of AP into direction cosines of axis. Coordinates of A and P are known. P is xyz and A is 1 minus 1 2. Therefore direction ratios are x minus 1 y plus 1 z minus 2. Direction cosines of axis are already obtained, 2 by root 14 minus 1 by root 14 and 3 by root 14. Then their component wise multiplication is taken, and then it is simplified to get AM equal to 2x minus y plus 3z minus 9 divided by square root of 4. Now we can use the Pythagoras theorem for triangle APM. So AP square equal to AM square plus PM square. AP square, so square and square root will cancel. Then AM square is written, and then PM is the radius of cylinder, that is 3 square is written. Then square down both sides, then multiplied by 14, and then simplified by usual method to get the final answer. So now you might have understood how the 2x minus y plus 3z minus 9 square is obtained. It is here, see, 2x square, here it is, then minus y square, then 3z square, that is 9z square, minus 9 square, that should be 81, by mistake it is written 91. Then 2x into minus y minus 4xy, 2x into 3z, 6xz multiplied by 2, 12xz, 2x into minus 9 minus 18 multiplied by 2 minus 36x. Now start with the minus y into 3z minus 3yz multiplied by 2 minus 6yz minus y into minus 9, 9y multiplied by 2, 18y, and then start with the 3z into minus 9 minus 27 multiplied by 2 minus 54z, and then 14 into 9 is 126, and then it is simplified. So instead of minus 42, I think a different number is there, since it is by mistake 91 is written. So you cross check it.